So continue in section 4.1. Let's talk about another vocabulary term, and that is a critical point. Critical points or critical numbers. Critical numbers. These are points where f prime of x equals 0 or f prime of x does not exist. Okay. Now I should say, for, let's see, a quick example here, if I had something like f of x equals x plus 2 divided by x, right, so that f prime of x, I guess I could write that as 1 plus 2 over x, right? Oops, f of x first. So that f prime of x, it'd be minus 2 over x squared. Okay, so in this case, what I wanted to say is that the question here is whether or not to include x equals 0 as a critical point. Notice that x equals 0 is not in the domain of f. Okay, and so therefore, even though x equals 0 makes f prime of x undefined, x equals 0 is not in the original domain, and so therefore we would not include it not include it in the list of critical points. Okay, so if it's not in the domain, we wouldn't include it, because we really only want to include points that are in the domain of our function when we're looking for maxes and mins. Good. Okay, so let's think about this. What we want to do now is we want to try to come up with an algorithm. For finding, well, maybe before we do the algorithm, we need to get a little bit of theory. Because before we are looking for a max or min, we better make sure a max or min is there. So under what circumstances, let me pause this and write this down. You're going to watch me spell circumstance. Okay, so under what circumstances can we guarantee that f of x has a global max or min? Well, it actually is pretty simple to, f doesn't really need much, and the idea here is that if you consider a function, f, with a closed interval from a to b, so notice that I'm using square brackets to denote that the endpoints are included in the domain. And then if you have a function, all we really need is that the function is continuous, because if the function is continuous, it kind of acts like a string between f of a and f of b. So I'm just drawing an f of a and f of b in here. And so when f is continuous, it's like a string that's being tacked into place, right? And on the string, of course, there's got to be a global max and global min, right? And so that's the idea behind the next theorem, and that is the extreme value theorem. Remember that we had a value theorem before, the intermediate value theorem. Now we have the extreme value theorem. Okay, so I'm going to pause for a second and write it down. Good. So the extreme value theorem says that if f is continuous on the closed interval from a to b, then f attains a global max and min on a and b, on the interval from a to b. So that's really not much, right? You don't have many things that we have to put on f in order to guarantee that we have a global max or min. Notice that f doesn't necessarily have to be continuous in order for us to have a global max or min, right? So for example, I may have a function that's like this, right? This function, did I want to max? I guess I could put a point here. So this is my interval from a to b. So notice that this function is not continuous, but it does have a max, a global max at x equals a. Oops, that should be an open circle there. Oops, that shouldn't be an A, that should be a C, maybe. Okay, good. And so this is the value here, right? This is my global max, so maybe I'll say this is 1, 2, 3. And so you can see that 3 is the global max of this function, but this function is not continuous, right? So the problem is that, by the way, does this function that you're looking at here have a local max at x equals c? In fact, it does. Yeah, it would be the same point. This is kind of a weird example, but okay. So anyway, getting back to the issue. So to guarantee that we have a global max and min on the interval, we need the function to be continuous on the closed interval. Good. Okay, so one other note about this theorem. This theorem does not tell us where to find the max and min, right? So we know that the max and min exists. This is an existence theorem. This is an existence theorem. Right? So it just tells us that we have one. It doesn't tell us where to find it. And so we need an algorithm to find the global max and min. By the way, we're going to be looking for local maxima later. Right now we're just focusing our algorithm on the extreme value theorem, or the global max min. So this is going to be called the closed interval method. I think that's what the book calls it. Good. All right.